Hello viewer, you are watching Elim TV. I'm introducing you to Form 1 Chemistry, Introduction to Chemistry, lesson number 1, and I'm going to be your teacher, Benjamin Makanda. Now, before we begin our lesson, to ensure that you follow this lesson, you can SMS your questions and comments on the number 40007. SMS your questions and comment on the number 40007. Welcome. Now, we are going to go through the specific objectives of this lesson so that once we finish this lesson, the following should be achieved. By the end of this lesson, the learner should be able to recall the topics related to chemistry taught at primary school level. Once we are done with all that we're going to discuss, the learner should be able to recall all the chemistry topics that were taught at the primary level. Now, our lesson is going to follow the following order. First, we are going to define matter, definition of matter, states of matter, properties of matter, to show that what matter occupies space. We are also going to look at drugs and drug abuse. And then we shall close the lesson by looking at a few questions that we'll attempt, which we shall discuss in our next lesson. So stay with me. Now, let's begin by making a review of chemistry topics that were covered in primary science. And the first topic that we are going to look at is matter. In our primary science, we discussed this topic, matter, and if I were to pose a question, what is matter? So, what is matter? Now, the definition of matter is anything that has mass and occupies space. Now, in that definition, we have two keywords, mass and occupies. So, mass means that any given material has some particles in it, and these particles are able to occupy or take up a space. So matter is anything that has mass and occupies space. Look around you. Anything you see around you is matter. And if you take it and maybe measure, you will get some quantity in it. Those quantities are what we call mass. The heaviness of an object is what we don't call as mass. And then when you take that object and maybe you place it on something like a table or a chair, there will be no space remaining. That means that that particular object has occupied or taken up a space. So that qualifies that particular material or object to be called matter. Now, we proceed on. 3 states of matter exist, namely, the first one are solids. Materials can be solids. We can also have materials that are liquids. These are still states of matter, and gases. So 3 states of matter exist. We have solids, liquids, and gases. States of matter. Now, matter is made up of particles, and these particles can be in the form of this particle that you're able to see here in our video. We have solid, liquid, then gas. Those are the 3 states of matter. The different states of matter are due to the different arrangement of particles of matter. So how the particles of matter are arranged. In solid state, the particles of matter are very close to each other, as you can see there. They are packed. The solid particles hold each other very tightly. That is, there are strong forces of attraction between them. So that force of attraction makes them stay together. Solids have a definite shape and volume. Then, in a liquid state, the particles are packed closely together. They have intermolecular spaces. The particles in liquid are much further apart than the particles in solids. The force of attraction in solids is weaker than it is in solids. Liquids have definite volume, but they do not have definite shape. Instead, they take up the shape of the liquids of the container in which they are kept, as you can see from the video. Then the last state is gas, and in gas, so like now we have the flame there. In gases, the particles of matter are very far apart from each other, so large intermolecular space exists. The force of attraction between the particles of matter in gases is very weak. Very weak. Gases have neither definite shape nor volume. So, due to this, gases can fill the entire space or volume of a container irrespective of the container size, whether it is small or big. So, that video explains to us the three states of matter. Now, having said that, now let's look at the three states of matter in order of the arrangement of the particles. So we can borrow this from the video that we have just watched, and the first state of matter is solid. Now, if you observe the particles of solids, these particles are regularly arranged and they are actually closely packed together. From one particle to the other, there exists an intermolecular particle in the molecular space. So we have intermolecular space between one particle and the other, which makes these particles to be compact. These arrangements of solids gives them their shape and their volume because of the strong force of attraction that exists between the particles. So the arrangement itself will give the solids the definite shape and volume. The next state is liquid. In a liquid, the particles of liquid are not as closely packed together as and you're able to see this from the diagram. In one particle and the other, there exists a large intermolecular space. This therefore makes the force of attraction between the particles of liquids to be weak, hence the volume of the container in which they are confined. And the shape of the liquids also assumes the shape of the container in which they are confined because of the large intermolecular space that exists between the particles, making the force of attraction to be weak. The last phase or property or state of matter is gas, and in gas the particles are further apart. This therefore makes the particles to have weak intermolecular space, intermolecular forces of attractions between one particle and the other. The force of attraction is very weak, and therefore these particles are able to break away from one another. They stay further apart. This therefore ensures that the particles of gases, and gas as one of the states of matter, neither does it have a definite shape nor volume. And from the video, you realize that it does not matter how small or big the size of a container is. The gas particles can be able to fit in any size of the particle of the container, irrespective of the size, due to the spread in the distance between one particle and the other. Property occupies space. So, does matter occupy space? Yes, matter occupies space, and we can be able to explain this from this. We insert a bottle. This bottle is filled with air, and if we insert an empty bottle in a bucket that has water, what's going to happen is that water is going to move up into the container, displacing the particles of air which are going to move out. And how do we tell that these particles are moving out? From the diagram, you are able to see some bubbles escaping. These bubbles confirm that air occupies space. And air, being one form of gas, is a state of matter. This therefore shows that matter occupies space. Or which other substance around you occupies space? Look at your books placed on the table. If you place the books all over the table and you want to take a cup of tea, where will you place a cup of tea? On the table or on the books? You realize that there will be no space because the books have occupied space. They have taken up the space you would have used to place your cup of tea. So this is another form or state of matter which occupies space. So we proceed on, and we still want to look at the properties of matter. And here is a summary of the properties of matter that we have been observing from our various demonstrations. So we are going to look at these properties. We look at the characteristics of the properties, and we are going to outline the characteristics of all the three states of matter, beginning with the solids, liquids, and then lastly gases. The first characteristic that is common across the three states of matter is shape. Now, let's look at solids. Solids have definite shape. What makes solids to have definite shape? It is because the particles of solids are closely packed together, and therefore the force of attraction between the particles is so strong that it gives these particles actually a shape that is definite. So if solids have definite shape, then we can be able to say this: we have solids that are regular. We can have triangular solids, rectangular solids, etc. Those are definite shapes that we can be able to define. What of liquids? Do liquids have definite shape? From our demonstration, definitely no. No definite shape in liquids, and the explanation behind this is that unlike in solids, the particles of liquids are further apart, and this therefore makes the force of attraction between the particles a bit weak, which makes the particles of liquids not to hold to one another, therefore losing shape. Instead, the particles of liquid will assume the shape of the container in which they are confined. Let us look at this example. Take some water and pour into a glass. Then tell me the shape of the water in the glass. The answer should be, first of all, what's the shape of the glass? A glass is cylindrical. Therefore, if the glass is cylindrical and you have poured water in the glass, definitely the shape of water is also going to be cylindrical. Conclusion: liquids have no definite shape, but they take up the shape of the container in which they are confined. So, looking at the same characteristics, we go to gases. Gases have no definite shape, just like in liquids, because unlike in liquids actually, the particles of gases are further apart, and therefore the force of attraction is negligible. So this makes the particles of gases to actually spread all over. So I want you to carry out this demonstration in 1 second. This experiment, wherever you are. Get hold of the particles of gases in front of your face. How many have you been able to hold? None of them. Can you explain this? It's because these particles are escaping from you. There is no force between one particle and the other which can bring them together. The force is so weak, so you cannot be able to hold these particles together. This therefore ensures that the particles of solid do not have definite shape. That is the first characteristic of solids, liquid, and gases. The second one is volume. So looking at solids, they have fixed volume. Solids have fixed volume. For example, if you take a loaf of bread, what's the shape of a loaf of bread? A loaf of bread is in form of a cuboid. Now, how can you calculate the volume of a cuboid? So refer to your mathematics. The volume of a cuboid is given by taking length, you multiply by width, then you multiply by depth or height. What makes us able to determine the volume of these particular solids is because, one, it has a shape. So this therefore tells us that because solids have definite shape, then we are able to determine the volume of these solids. So it is very true to say that solids have fixed volumes. So what of liquids? Liquids have fixed volume. They also have fixed volume because when you pour liquids into a shape like a cylinder, then you are able to calculate the volume of a cylinder using the formula that is there. Volume is given by pi r squared multiplied by height in your mathematics. Otherwise, gases have no definite shape, and we can tie our explanation from the first property, which tells us that no definite shape. In terms of density, because of the particles of solids are closely together, solids are very high. The density of solids are very high, while in liquid their densities are also high, but in gases the density is low. The fact is that because the intermolecular spaces between them is very low. So the other property or characteristic is the flow. Do solids flow? Solids do not flow because of the strong forces holding them. Liquids flows easily because of the weak forces holding them. However, in gases, the flow is even easier because the force of attraction is actually negligible. Packing of particles. The particles in solids are closely packed together, but in liquids some spaces is left, while in gas in terms of the characteristics. Now let's look at drugs and drug abuse. So what's a drug? Drug is a substance which is used as a medicine or in medicine. Some drugs occur naturally in some plants and animals or are man-made. And here we have a sample of commonly used drugs, and these are drugs commonly used for children. Now, having said that, what about drug abuse? It is the use of drug for a purpose which it is not meant for, or when an overdose or underdose of drug is administered, we call that drug abuse. Drug abuse has harmful effects to the state of health of the users, and we can have this here. These are drugs of abuse. From the photos here, you can be able to see some of the commonly abused drugs. What are the effects of drug abuse? So this one gives us a summary of the effects of drug abuse. We have 4 effects. 1, you get addicted. Addiction, it can cause addiction. It can also cause medical problems, as you can see there. It has also economic implications when you continue using drugs. And lastly, it also has social effects. Up to there, we come to the end of our lesson. And before I summarize my lesson, I leave you with these questions that you will attempt. And when we meet back in our next lesson, you will be able to discuss with me these questions that I'm going to give you. So this is your assignment that you're going to attempt. You are going to define drug. What is drug abuse? Number 2, list 3 effects of drug abuse. Number 3, mention 4 ways of preventing drug abuse. And lastly, number 4, name 2 control agencies on drugs. So that's your assignment in this lesson. Remember, this was lesson 1. Now in lesson 2, we shall review these questions before we move to our lesson number 2. So thank you very much for following me up in this lesson. I've been your teacher, Benjamin Makanda. Until next time, stay tuned.